Welcome back. We're looking at diversity, change and continuity. We've just investigated the Cambrian explosion. We're now going to look at another interesting topic, missing links or transitional forms. Now, the fossil record, which is kind of a catalogue of all the different fossils that have been discovered, the fossil record refers to all the fossils that have been discovered, and we need to remember that the fossil records are not complete. They do not always give us a true indication of every single species that existed, and I'm sure you can think of some reasons for that. Animals like jellyfish, for example, that consist of soft tissue, don't fossilize very successfully. And practicality, most land animals don't die near mud and sediment, and so the conditions and the kind of animal, the conditions for fossilization and the kind of animal has to be very specific, and so very few organisms actually become fossils. However, when the fossil record is taken, the catalogue of all the fossils that have been discovered, and they're arranged in age from the oldest fossils up to the youngest fossils, they often provide excellent evidence of successive changes in strains of organisms. The fossil record provides much evidence of what we call transitional or changes or intermediary forms. An intermediary is a type of fossil that exists between two other kinds. Transitional fossils are fossils that are intermediate between the ancestor and the descendant. And so we know that some particular form of organism was the ancestral form. We know that another form of animal was the descendant. We can look and see, are there transitional forms? Are there links between ancestor and descendant that show us how this organism developed? Now, there are many examples of these intermediary or link organisms. Let's have a look at a couple. The forms between reptile and mammal. Reptiles have jaws made of 4 bones. Mammals, our jaws are made from 1 bone. We have found fossils of reptiles that show this transition from 4 bones to 1. Reptiles also have undifferentiated teeth. All their teeth look the same, whereas mammals, as you know from your own mouth, have incisors and canines and molars. They have differentiated teeth. There are many fossils, once again, that show this transition from many bones in the jaw to a single bone in the jaw, undifferentiated teeth, to descendants that have differentiated teeth. There are also fossils showing the transition from a 4-legged mammal that lived on land to aquatic mammals such as the whale. The fossil whale, Basilosaurus, has tiny hind legs. So once again, we can see that the Basilosaurus is an intermediary between land mammals that have legs, 4 legs, and whales that have no legs as such, although they have their limbs in the form of flippers. Many fossils exist showing the changes from a very small rodent-like animal to large hoofed horses. Human evolution is particularly rich with many intermediary fossils, and more are being found all the time, which is very exciting. 2 of the most famous examples of these intermediary or link fossils are that of Tiktaalik and Archaeopteryx. Now, this is a picture of Archaeopteryx, but Tiktaalik is thought to have lived in shallow water, very close to the shore, in areas where there was a lack of oxygen dissolved in the water. Now, if the animal needed oxygen and there's a lack of oxygen in the water, the place to go for more oxygen, of course, is out into the air. Well, Tiktaalik had scales a very fish-like tail, but it also had spiracles or little holes in the tops of their heads, and with that, Tiktaalik could breathe air, as well as having gills for when it was submerged underneath the water. They had ribs, and they could support their weight on their fins. So scientists think that Tiktaalik may have spent short periods of time on land and also kind of walked or pulled itself about in the shallow water, lifting their heads up if they required oxygen. And so scientists have thought that Tiktaalik is a transitional fossil organism between fish and tetrapods such as amphibians. An important example of another kind of transitional fossil showing the development from reptile to bird is Archaeopteryx. The name actually means ancient wing feather, and Archaeopteryx lived about 150 million years ago. Like the birds, it had feathers and wings, but we don't know if it could actually fly. If its bones were still too heavy, it might have just glided very fast. So scientists have very little doubt that a group of dinosaurs gave rise to the birds and that Archaeopteryx may have been one of these transitional forms. More about diversity and change after the break.